A particle of weight 120 newtons is placed on a fixed rough plane which is inclined at an angle alpha to the horizontal, where tan alpha equals 3/4. We draw a 3, 4, 5 right angled triangle from which we can read sine alpha is 3/5, cos alpha is 4/5. We draw on the normal reaction at right angles to the inclined plane. This reaction will make an angle of alpha to the vertical. We're told the coefficient of friction is 1/2. Friction may be operating up the plane or it may be acting down the plane. We have to show the normal reaction is 114 newtons. And in this case, it doesn't matter which direction the friction is acting. So we resolve forces perpendicular to the plane, and we get that the reaction R equals 120 cos alpha. That's the component of the weight acting perpendicular to the plane, plus 30 sine alpha. That's the component of the force of 30 newtons acting perpendicular and into the plane. From this, we can calculate that R must be 114 newtons. Now the situation changes. The horizontal force is removed and replaced by a force of magnitude p newtons up the slope. The particle remains in equilibrium. We have to find the greatest possible value of p. So here we resolve perpendicular to the plane, and we get R equals 120 cos alpha, so R equals 96 newtons. We resolve along the plane, and given that the particle is in equilibrium, we can see that P equals 120 sine alpha, that's the component of the weight acting down the plane, plus the friction, F. The maximum value of the friction, F max, will be mu R, which will equal 1/2 of 96 newtons, which equals 48 newtons. P max will be 120 sine alpha plus F max, which equals 120 newtons. If P is 30, substitute 30, we can see that F equals minus 42 newtons. The magnitude, therefore, of F is 42, and as it's negative, it means that F must be acting up the plane. So the direction is up the plane.